Hello students, welcome to this video on Mathematics program for grade 9. This is part 2 of a series of 2 videos on coordinates. In this video, we are going to learn about equation of lines. I am Paudesya, lecturer at MIE. Objectives: at the end of this program, you will be able to determine the equation of a straight line in the form y is equal to mx plus c. Let us have a recap on part 1 of this series. In part 1, we learned that we can measure the steepness of a line by calculating its gradient. Gradient is equal to vertical increase over horizontal increase. And the formula is y2 minus y1 over x2 minus x1. We also learned that horizontal lines have gradient equal to 0. Vertical lines have gradient undefined. Lines that are inclined upwards have gradient positive, and lines inclined downwards have gradient negative. Let us come to equation of a straight line. In earlier grades, you learned about equations of vertical lines or lines parallel to the y-axis. Let us consider this vertical line. It crosses the x-axis at 5. If we plot different points on the line, you will observe that the x-coordinate of each point is same as the point where the line crosses the x-axis. That is, in this case, it is 5. Therefore, the equation of this line is x is equal to 5. Let us now place the line at x is equal to minus 3. Therefore, the equation of this line will be x is equal to minus 3. If the line is placed at x is equal to 0, that is, the vertical line is crossing the x-axis at 0, the equation is x is equal to 0. But observe, dear students, that this vertical line is also the y-axis. Therefore, y-axis has equation x is equal to 0. Let us consider the value of x as h. If a vertical line is crossing the x-axis at h, the equation of that line is x is equal to h. We now know that vertical lines or lines parallel to the y-axis have equation of the form x is equal to h, where h is a constant. Let us consider equations of horizontal lines or lines parallel to the x-axis. This is an example of a horizontal line crossing the y-axis at 1. If we plot different points on the line, we'll observe that the y-coordinate of each point is same as the point where the line crosses the y-axis. That is, in this case, is 1. Therefore, the equation of the horizontal line is y is equal to 1. Now, let us place the horizontal line at y is equal to 4. Because the horizontal line is crossing the y-axis at 4, the equation of the line is y is equal to 4. We now place the line at y is equal to 0. That is, the horizontal line is crossing the y-axis at 0. Therefore, the equation of the line is y is equal to 0. But observe, dear students, that this line is also the x-axis. Therefore, we have the x-axis has equation y is equal to 0. If we take a general value of y, that is k, a horizontal line crossing the y-axis at k has equation y is equal to k. Therefore, we have horizontal lines or lines parallel to x-axis have equation of the form y is equal to k, where k is a constant. Let us now consider equation of line not parallel to the axis. This line crosses the y-axis at C, where C is the y-intercept. But remember, dear students, that the equation of this line is not y is equal to C, as this line is not horizontal. Suppose that the gradient is m. Equation of a line not parallel to the axis is in the form y is equal to m, that is the gradient, multiplied by x plus c, that is the y-intercept. Y is equal to mx plus c. Let us take an example. In this case, the y-intercept is 3 and the gradient, that is m, is 4. We know that the equation of line is in the form y is equal to mx plus c. If we replace m and c in the equation, we have y is equal to 4x plus 3. In this example, the line is inclined downwards and crosses the y-axis at 4. That is, the y-intercept, or c, is equal to 4. Because the line is inclined downwards, we know that the gradient is negative. Suppose that in this case, the gradient, that is m, is minus half. We know that equation of line is y is equal to mx plus c, and in this case, c is equal to 4 and m is equal to minus half. Replacing m by minus half and c by 4, we have the equation of the line y is equal to minus half x plus 4. Let us now consider this example. Find the equation of the line passing through the point B with coordinates 1, 3 and gradient 2. Observe, dear students, that in this case, the gradient and the coordinates of a point are given. The gradient is equal to 2, that is, m is 2. And the coordinates of point B are 1, 3. Let us label the point B on the line 1, 3. We'll observe that equation of a line not parallel to the axis is given by y is equal to mx plus c. In this case, m is known, but the y-intercept, that is c, is unknown. We can find c by using the coordinates of the point B. Let us label the coordinates by xy and replace these values in the equation. 3 is equal to 2 multiplied by 1 plus c. This way, we can find the value of c, and in this case, c is equal to 1. Therefore, equation of line is equal to 2x plus 1. 2x plus 1 is the equation of this line. We have used the gradient and the coordinates of a point to find the equation of this line. Consider this example. Find the equation of the line passing through the points A with coordinates 1, 2 and B with coordinates 4, 4. In this case, the coordinates of 2 points A and B are given, but m, that is the gradient, and c, that is the y-intercept, are both unknown. But we know that gradient is equal to vertical increase over horizontal increase. And the formula is y2 minus y1 over x2 minus x1. We can replace these values to get the gradient. In this case, m is equal to 2/3. We have the gradient 2/3, but the y-intercept is still unknown. In our previous example, we used the gradient and the coordinates of one point to find the value of c. Here we have 2 points, A and B. You can use any one of these two. Let us choose the point A and label the coordinates by x and y. We have equation of line in the form y is equal to mx plus c. We can replace the values of y, m, and x to find the value of c. In this case, c is equal to 1/1/3 or 4/3. Therefore, the equation of line is y is equal to mx plus c. We can replace m by 2/3 and c by 4/3 to get the equation of the line. We can further simplify this equation by multiplying by 3 on both sides to get 3y is equal to 2x plus 4. We now consider gradients of parallel lines. You will observe that the y increase or the vertical increase and the horizontal increase in both lines are same. Therefore, observe that parallel lines have equal gradients. Because one of this line has equation y is equal to 2x, that is, the gradient is 2, the gradient of the second line is also equal to 2 because they are parallel lines. Remember, parallel lines have equal gradients. Let us consider this example. Find the equation of the line passing through the point D with coordinates 1, 6 and parallel to the line y is equal to 2x. We know that parallel lines have equal gradients, which means that because the gradient of the first line is 2, the gradient of the second line is also equal to 2. We know that y is equal to mx plus c is the equation of the line. We can use the gradient and the coordinates of point D to find the value of c. In this case, 6 is equal to 2 multiplied by 1 plus c, where c is equal to 4. Therefore, the equation of the line becomes y is equal to 2x plus 4. Dear students, here are some exercises so that you can practice your knowledge of equation of lines. You have also been provided with 2 websites so that you can consolidate your knowledge of equation of lines. We have come to the end of this program. Let us have a recap. First, we learned that vertical lines or lines parallel to the y-axis have equation of the form x is equal to h, where h is a constant. Horizontal lines or lines parallel to the x-axis have equation of the form y is equal to k, where k is a constant. And equation of line not parallel to the axis are in the form y is equal to mx plus c, where m is the gradient and c is the y-intercept, that is, where the line crosses the y-axis. We also found that parallel lines have equal gradients. We have now come to the end of this program. Hope that you enjoyed this video. Thank you and goodbye.